machine learning. Let me know if I need to talk louder. All right, so let's get started. So about myself, I'm a Ruby on Rails developer. I work for a residential real estate company out of Bellingham called Ben Kinney. We're hiring if you're interested. I'm also a dog and cat lover. So meet George. He is our miniature poodle mix. We got him from the Seattle Animal Shelter, and he is very high strung and likes to bark a lot. Oops. But we found that George likes the sound of rain if he's barking a lot, and we play some calming rain noises. He'll meander to his bed and he'll start to take a nap. So it's, this is Oliver, by the way. George found Oliver, this kitten, underneath our duplex as a kitten. He was abandoned. So we welcomed him into the family. So it'd be so nice, right? Like when George barks, we play rain, he goes to bed, everyone's happy. So I work from home, and so this is a common occurrence where like I have my Rain MP3 on my desktop. I have VLC open during the day. I live it's like a 10-hour clip, and I just like am, you know, playing it all the time when he starts barking. So it sounds like a difficult problem, right? Like we want to, how are we going to do this? We have George barking, he's out of control. We need to play this rain, but don't know how. We, you know, we're programmers, we can figure something out, right? So this begins the journey on how to detect the dog barks and play rain noises. So my first idea was just to make a simple script that listens for a threshold of volume. So when we listen to a sound that's very loud, we start playing rain. Unfortunately, this had a lot of false positive from cupboards, for example, because those would be pretty loud and so we would just have all these false positives. And just so you can visually see this, here we have the bark at the top, and we have our threshold, and here's like our stubborn cupboard is just in there, and it triggers the rain noises. So next I thought, oh, like what's this audio fingerprinting? This sounds kind of cool. I thought, you know, let's say we have a George bark, we take the fingerprint of his bark, and then we have a new sound come in, we take the fingerprint of that, and we compare it to the original fingerprint, and if it matches, maybe we know this bark, and we can play our rain noises. Unfortunately, this is not how audio fingerprinting works, but this is how Shazam works if you're interested. Audio fingerprinting works when your source and what you're trying to match with are like very closely it matches. It's like the same song. You know, maybe you got some noise, like it's one of them is on the radio, like pretty much the use case for Shazam. I thought this was kind of cool. This is an example, like audio fingerprinting algorithm. Like this, if you can see the yellow and green. So the bottom is the original song. The top is our audio, and you can kind of visually see how it matches with that yellow and green. So then it knows that sound is the original sound. And so we can imagine, like, if we had a bark as our original bark, and we had a new sound coming in that's also a bark, you know, every bark is different, and so it's not going to match like on that detail. Another thing I did, so I work from home. My wife Rachel, when she comes home from work, as soon as George has very good hearing, as soon as he hears the car pull into the driveway, he hears the doors close, he starts going bananas. And so I thought another thing that would help was to start playing rain right before Rachel comes home. And so I built like some scripts and it pings Rachel's phone continuously. Using Find My Phone, and when she's like within like 5 miles or something, it starts playing Rain. So this is to kind of like drown out the car noises, and it works pretty well. So yeah.
Is that draining the battery on her phone?
Maybe, but not my problem.
Did she know about that before just now?
She was getting all these, every time there's a Find My Phone initiated, she gets an alert, like an email or something. So she's like, I spam her with all these things. Right, so this brings us to machine learning. Like, I didn't really know what machine learning was. It sounded very complicated. But it sounded, so after doing more Googling and research, it sounded interesting. I came across a project that used machine learning to classify sounds, if the bird sound is a kiwi male or a kiwi female bird. And so I was like, oh, this is kind of similar to dog barks, and we're comparing like these, we're trying to classify these sounds, so maybe this could work for this use case. All right, so what is machine learning? Just on a high level, it's a way for us to organize data, and it does this by finding patterns. And we'll kind of walk through how we use machine learning in our use case. Hey, maybe the dog can help demo at the end. And so in our case, right, we have a house of sounds. We have sounds from everywhere. We have sounds from the cupboard, we have sounds from like the dishwasher, we have people talking, we have music. So we can imagine that as one giant blob, right? That's one giant blob of sounds. And then we have another much smaller blob of sounds that are comprised of George barks. And so what we want to do is we want to, group this data apart, right? We have one blob that's like the non-barks, and we have one blob that's the barks. And so we want to use machine learning to help, if a new sound comes in, is this new sound part of the first blob, or is it part of the second blob? And it does this by looking at the patterns like within the audio, which we'll get into. So when to use machine learning, it's when we don't want to solve this programmatically. Like, as we talked about before, barks are like snowflakes, and so if we were to solve this problem programmatically, here's some more audio samples, and this is just the X is time and Y is volume, but we can kind of think we know what a bark sounds like, we know what a cupboard, and someone's saying the word clarification. We could programmatically try to look at these audio characteristics. We know we can see the length, right? We can see how loud it is. We can also imagine like the frequency as this goes on. We can try to, a bark is going to have this length, this loudness, this kind of frequency, and there's a bunch of other audio features we could look at. But with using this programmatically, it's difficult, and machine learning offers an easier way. So what are our requirements for machine learning? So first, we need a lot of data. We need a lot of data for each group that we have. We have our grouping of our house sounds, and so we need a lot of data for like lots of cupboard sounds, we need lots of dishwasher sounds, and all the sounds that we can think of, we need lots of samples. And then we need, of course, lots of dog barks. And it's important to note that you can't have a negative example. We can't say, oh, if it doesn't match these two things, it will match the third thing. Like, we need to match positively to each grouping. So you always need to have lots of data for each of your groups that you're trying to match. And so another thing that we need good audio features. And we'll get into what audio features are in the next slide. And then we can put it all together with a library like scikit-learn, which is a Python library. And they have great tutorials, by the way. Right, so the first thing is we need lots of data, right? And like we talked about, we need lots of data from each group. One thing I'm struggling with is I don't have enough barks. I can record continuously all day, 24 hours a day, and get all the household sounds right. But George doesn't bark 24/7, and so my distribution of sounds right now is very uneven. And so part of my problem is trying to generate more barks, and I've even I've been like barking myself and trying to get yes. So we need good audio features. And so first, like, what is an audio feature? Like, what's a feature? A feature is a measurable numerical value. So we can think back to when we talked about, we were looking at those 3 audio clips, and what are some measurable numerical values from those audio clips? We know that one of them could be the length of the audio clip, one could be like how loud the audio clip is, one could be like the frequency. So those are all measurable numerical value. And these values will help distinguish the barks from the non-bark sounds. And what I found is you need to do research on this. Like, it's going to be, I think, difficult to find good audio features. And I found that, like I mentioned, the Kiwi Bird project, the man Lucas, like, he found he had really good audio features. The audio features I didn't know existed. So like, I plan on doing more research. Like, there are actually like quite a few papers on machine learning with dog barks, and so like they describe which audio features they use, and so that's something I plan on doing, is looking at what they used and trying those out. So one thing to note is as you increase the number of features, you need to increase the amount of data you have. So I wanted to cover like a good example and a bad example of features. Here's one of the audio features that's in the project. It's called spectral flatness. I don't know if anyone's heard of this. I had not heard of this. It is a higher value correlates to white noise, and white noise is a sound that contains all frequencies, and it sounds like shh. That's white noise, and then a lower value corresponds to a pure tone, like. So here we can visually see what spectral flatness looks like for the word. There's someone saying clarification. And as you remember, the lower values towards 0 are more tonal, and the higher values are more white noise. And just looking at this, honestly, it looks like the consonants are more white noise, like in clarification, and like the vowels are more tonal, like, and that's what seems to make sense. And I thought that was really interesting. Oops. Oh. So here's an example that wouldn't be just a great feature to use with classifying dog barks. You know, these would be great features in other applications. But for trying to classify a new sound that comes in, let's say at 3 p.m. and it's 70 degrees in the room, that's not going to help us distinguish if that sound is a dog bark or not. But let's say temperature would be very important for determining what a good French fry is or something. Right, so we have our data, we have our good audio features, and we put all that together with a library. I was using that scikit-learn from Python, and the next step is you want to label your data as a bark or a non-bark. And so in our case, we have 2 labels, and they just correspond to a numerical value. It's 0 index, so like, just happen to label non-barks as 0 and barks as 1. And so with our data set, we label each of our, so for our first sound, we have a bark. We label that as a 1, and we have all the features associated with that sound, right? And so we have this big array of all of our features, and we have another array of our labels, and those labels correspond to the rows of features. So we feed this data into a library to generate our model. And this is kind of visually just to see what it looks like. Here we have our classifier object, and we pass in the features, we pass in the labels, and so the index corresponds on the features and labels to the same sound, right? So the first feature corresponds to the first label. And then that's where you have our model. And then this pickle is a serializer for Python. So we just dump our object and just call it model. And then we can use that later. Yeah. So now we have our model. If we want to classify new sounds, we just load up our model. And so we have our new sound come in. We calculate the features on the new sound. We pass those features into the model, and we get our prediction. And our prediction is going to correspond, it's going to return a numerical value, which will be one of our labels. So if you remember, we had 0 for non-bark and 1 for bark. So the prediction will either be a 0 if the sound is predicted to be a non-bark, or a 1 if it's predicted to be a bark. I thought this was really cool. I found this slide online. It describes a lot of different really cool applications for machine learning. You know, one thing I thought about is applying the machine learning for work in terms of web applications. You know, thinking about like, oh, you have a customer, maybe we could, because one thing you can do with machine learning is also return a range. Like, let's say we want a customer satisfaction of 1 to 10, and we have all our data and we calculate our features, and we could, given certain data from a customer, return a range of 1 to 10 and see if we need to pay more attention to that customer, or if they're already really satisfied, we can try to sell them more products. There's also this really good paper I thought that's on predicting online user behavior it's called Using Deep Learning Algorithms. You can check that out, I recommend it. I thought it was cool because now we know what features are, and so it's pretty cool to look at. Like, here's this example that we can see the features that they use. Like, they use stuff like duration on the website, all this stuff that we're familiar with. Right, it's interesting to note that their data set is huge. They have tens of thousands of page views, and their data set is it's very impressive. All right, so just talking about the machine learning types. There are different types of machine learning depending on what you're trying to accomplish. We just walked through what's called supervised learning. That's when you want to classify, let's say a sound is a bark or a non-bark. There's another type called unsupervised learning. Let's say, and this is with a fixed data size, like we don't have new incoming data. We have, let's say, one large group of data, and we want to look for patterns and groupings within that data. And I'll show you an example of that. And then reinforcement, this is like a self-driving car receives real-time feedback on how it's driving. It can receive like positive feedback that's on the road, or like negative feedback is going towards the railing or something. Yeah. Right, so we just talked about supervised learning. This is where we label our sounds, our audio features as a bark or a non-bark. We create our model, and now we have that model. It can classify a new feature group as a bark or a non-bark. And it can also return a range if that's what we're looking for. And unsupervised learning, we discussed that we're just trying to cluster data into different groups. And here's an interesting application. So this is actually mushroom data, and I don't know what data features they use. Like, you can imagine that maybe they use the dimensions of the different mushrooms. Maybe the color, or like chemical composition or something. But it's interesting, like maybe these groups are like different mushroom species or something like that. So it's interesting. So with unsupervised learning, you have your big data set, you have your good features, and now you can like see, wow, I have one cluster is very distinct over here, and you can imagine if you did this for sounds in your house, maybe you could see some groupings and maybe we'd have like a small grouping of George barking or something. All right, so now I'll just kind of go over like a high-level implementation of the project. So we have like a microphone with a Raspberry Pi. We continuously record. We want to classify the incoming sounds, if it's going to be a bark or not a bark. And then, of course, we want to play rain when George barks. So as I mentioned, I based this off of a project. I cloned a repo that's called Ornithokrites. Which means it means interpreter of birds. Very graceful. It's because he's interpreting Kiwi bird sounds, right? He's trying to classify if an audio clip contains a male Kiwi bird, a female Kiwi bird, or even both Kiwi birds. So first, we want to read the bird's audio file. It cleans the audio, and by this it removes like audio clicks and other kinds of noises. It also removes like frequencies we know that like aren't applicable, like very high frequencies that the Kiwi birds don't emit. Then we can remove that audio. And then eventually I just updated that to remove dog frequencies that George isn't gonna bark that high or something. So the next step is to segment the audio. So we have our big clip. You can imagine there's lots of, it's a multi-minute clip, and we just want these what's called regions of interest. And so it just finds like, it finds the beginning of a noise, and then it adds some padding, and then it finds the end of it, and this stuff is configurable. It's about like a second long or something. So the goal of this is we want to remove all the silence. And then with this segment, that's when we calculate all the different audio features. So this stuff's really awesome, right? He has 8 different features. I've never been so excited about like features. It's so cool. So we can see our spectral flatness, and there's all this stuff that's it's pretty fascinating. So just so here's all the calculated features. We just have our array of so this is one segment, and these are the features calculated for that one audio segment. Right, so now we have our segment, we have our calculated features from that segment, we load our model from the disk, and now we pass in those features from a segment into the model, and then it classifies it as a male, female, or has both Kiwi birds. Okay, so here's some of the functionality I added to help adapt it for George. So of course, instead of just reading a file from disk, we want to stream continuously from a microphone, and we want to play rain when a bark is detected. Another cool thing is now we can record audio segments. We record each audio segment that is captured. And the reason why we record each audio segment is we can look at that audio segment later, and if the model was wrong about predicting that, we can change that. We can then re-upload that segment that it got wrong with the appropriate label, so we can continuously improve the model. Right. So we have our sounds that are downloaded, and then we just move them to the different folder categorized data, and we have some directories there, barks or non-barks, and that acts as like a label. So then you can run the program and reading the data from this categorized data folder, and it's going to, so I have a database running, and it calculates those audio features and loads them into the database with that label. So we can imagine our database, each row is a sound segment that contains all the audio features, and also contains the label if it's a bark or not a bark. Right, so now, and then we have another script that will regenerate the model from the entire data set in the database. and then we can use this new model and do new predictions on the new sounds. So the current status, like I said before, I have tons of non-barks, 7,000. I only have like 100 barks. I was on Sunday. I was like trying to improve the model like by barking myself. But like I still need more barks. But I'm still optimistic. I think if lots of companies do things like voice recognition and very complicated things, this is not nearly as complicated as that. We're just trying to classify a dog bark. And so I think with enough data with barks, I think it's a great application for machine learning, the supervised. So another thing I plan on doing is testing the model. So this is where you want to see how good your model is. So what you do is we split our data, our labeled data, into two. So we have our database, right, of all of our features that contain the label and the features. So we split that into two. We use half of it to generate the model. And then let's say, so we still have half the data set remaining, right? And with each of the remaining data set, we have the features and we have the label that is correct, right? So if we have that model already generated, we can take one of the remaining database rows, we can pass in the features, and then we can see, is it returning a 0 or 1? Does it think it's a bark or not a bark? And then we can compare that to what it actually was, right? And we can see if it got it right or wrong. Then we can see, we can strive for a high, accuracy percentage. Right, so my overall goal, I'm very passionate about this. As you see, I've tried many different approaches. I want to create first I need to create a large open data set of barks. And then I want to build a good model. One thing I found recently, Amazon has a machine learning program, I don't know what to call it, but you upload your whole data set, like we have all our features and are labeled. You push all of that to Amazon, they'll split it into a training set and a testing set, and they'll try different machine learning algorithms, and then it'll provide you the algorithm that has the highest accuracy, which is pretty neat. Yeah, I mean, I have a VirtualBox if you're interested in playing around with this. So I changed, when I moved the code to the Raspberry Pi, I had to change the Python audio library, and so it's not working right now, but I'll get that fixed. Yeah, here's just some links if you want to check it out. There's the scikit-learn. There's also I've heard a really good machine learning Coursera course that's from Stanford. And here's just kind of a screenshot of what it looks in practice. First we record our clip, we recorded it. Each of these items in the array corresponds to an audio segment. So we had 2 audio segments, and they were classified as both 0, which means it classified both of those as not a bark. Then we save both of those later if we want to, if we want to use that data to improve the model somehow. Then we keep going, and then the next we had 2 more segments, but one of them was 1, which means it detected a bark. And so now it says we play our rain noise. Yeah, so that's it. Thank you. I try to demonstrate this. You have to be very quiet. All right, you can't see this. Let me just go into mirror mode. All right, it doesn't want me to type there. All right, you can kind of see this. Make it bigger, I guess. So here's kind of our stream mode. Eventually, it's like we'll be able to pass in, let's say, like your microphone. Your microphone has like a hardware location, and so like right now I have to have it hard coded. Let's say we want to stream your data. First, I don't know. So what I did was it wasn't working very well. It needs more data, and so I did a new model on Sunday of just me barking, and this one example, and then the other example was me saying "Hello World 1 2 3" over and over and over again. And so that's what I will attempt to test. It's not perfect. I think it is better than random, at least. It's not production ready. Okay. Hello. All right, see, it didn't work. All right, let me try again. World. Hello. 1. All right. Not going very well. Okay, now at least, hey, I got that at least. All right, well, you get the idea. All right, thank you.
Question.
Oh yeah, what's up?
Have you looked online for other like libraries of dog barks?
I have looked online, like on YouTube, you know, like they're definitely dog barks. And I was like really excited. I saw one for 10 hours. I was like, oh my god, this is perfect. But then it was just looping the same bark over. But yeah, I definitely looked. There definitely are. I just gotta keep looking. You know, maybe there are other people like me.
I've seen things where people are Foley artists and they need stuff like that. Like you're doing background for television or film, you need off-screen or background sound. So there's people who do. If you look for something like a Foley, Foley sounds.
Of what sound?
Foley,
Foley?
F-O-L-E-Y.
Oh, okay, that's like the
It's like
term for
if
it?
you're in the film industry and you're trying to do like walking
Yeah,
and
like
then you like
that.
click, 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 click.
That's so cool. Okay, I'll start.
That's
I'll
an
go to
another.
Does someone have? I thought I saw a hand. I don't know.
SPCA, yeah. All right,
Cool.
start
Anyone?
calling out Kate.
How do I invest in your startup?
Yes, just talk to George. He takes treats.
I feel like you really missed an opportunity to bring George.
Yes.
To do a live demo.
Yeah. Absolutely. Yeah, what's going on? Yep.
How are you securing the folder of non-barks you've been recording in your house?
How are we securing those?
Yeah.
Yeah, it's not secured at all. Like literally, so what I had to do, right? I recorded for 2 days straight, and like I just ran this program. So it was storing, categorized stuff in the non-barks of art. So it was just all these audio segments, and then I just wore headphones, and I was just laying on the couch, like falling asleep, listening to these, and with the VLC playlist, just going through. And then like if I heard a bark, I'd pause, find it, and then move it to the bark folder. But yeah, it was literally just audio clips of me like talking on like and then like clips of music, and but yes, it's definitely not secured, but at least it's all local, so it's like it's not being sent up to some third party. But yes, that is a concern. Yep.
Hey, can you do the what happens if you do categorize the learning? So can I just keep it on for like a whole month and then maybe they get something categorized?
Sure. I mean, like we could definitely try that with using these audio features and see what happens. That could be interesting.
So like I'm thinking like maybe you can remove the manually select that part. So
Sure. Yeah, so it's like you can do that and then see what it categorizes, and like, oh, does it really see George's marks and just use all the other ones? Is that kind of what you're getting at? Or?
so like can it magically? So I just put whole months of audio, and then it just automatically categorize several stuff, and
Yeah.
then like okay, that category is exactly the bar, and then just select that. So you don't have to do the menu like labeling.
Right. Yes. Yeah, you could. I mean, you'd always, I think, want to make sure, because like it could potentially miscategorize one of those things as not a bark or something within that group, right? It could have like, oh, this is a group that sounds like bark, but one of those could be. I mean, personally, I would like verify that each of them are barks just to make sure that the data is solid. Yeah. So go ahead.
How accurate is your training data?
mean, I haven't tried that yet. I'm assuming very poorly right now. But one thing that I wanted to mention that would be really cool, like the next step that this works really well was, so you can have more than 2 labels, right? We have one label for non-barks, we have another one for barks. Let's say we introduce a third one, which categorizes all the sounds that trigger George to bark. So like trucks, knocks, stuff like that, and then like we start playing the ring then, so it helps drown out that sound, and then it would shorten the barking duration. That's like ultimate goal. This automate, yeah, that's what it would do.
Then you could try to like predict when those were gonna happen.
Absolutely, that'd be awesome.
I mean, I'm sorry to rain on your parade. That was not an intentional pun. Like, I feel like you might just like want to have this sound playing in your house.
Yes, that is a very good point. Like we have a something that does that. And what's cool about it, it's reactive, and so like if there's a noise, it plays louder, and so like it will increase in volume as there's noise, and so like it helps like if he's like often like so if he barks, then the waves will be louder, and so then that helps. Sweet. All right. Well, thank you.